Hey, we have here today another integral from the MIT Integration Bee 2023. This was quarterfinals, round 2, problem 2. We have the integral of 1 minus 2x over 1 plus x squared, x to the 2/3 dx. Okay, I didn't really know where to start with this because there was quite a few options. I was thinking maybe we could multiply this x 2/3 in. I was thinking maybe integration by parts could work. But what I did instead to start was just to do some algebra and bring this x to the 2/3 into the numerator as an x to the minus 2/3. And then when I multiplied my x to the minus 2/3 into the numerator, we get this configuration here. And at this point, I noticed this actually looks a lot like the quotient rule. Okay, I have my formula for the quotient rule over here on the right. And you'll notice the similarity here where we have something squared in the numerator. And then looking at our numerator, okay, we have the subtraction, but also notice the derivative of x to the 1/3 is going to be 1/3 x to the minus 2/3. So there's a real similarity there where we have this f and we have this f prime. And so the way I want to look at this is imagine if we're integrating on both sides, well then the integral here is just going to be f of g. And so if we have our integral here in this form, then our solution is just going to be f of g. So just looking at this, we know that if our denominator needs to be g squared, then we're saying that our g value just needs to be this, which is 1 plus x. And so we're going to have our g prime value, which is just the derivative of this, which is just going to be 1. Now with that, what we can check is we want this value right here to match this value. So we're saying this needs to be f g prime, where g prime is just 1. So that really goes away. So we're really just saying that our f value needs to be 2x to the 1/3. So then let's take a derivative and see what that is. So our f prime value, just using the power rule, is going to be 2 over 3x to the minus 2/3. And then with that value, now we have everything we need to calculate f prime g, which we want to match this. So then for our f prime g, let's just see what that works out to be. So we're going to have this 2/3 x to the minus 2/3, and we want to multiply it times this guy. So now we see a problem that this value actually doesn't match this right here. We're off. So let's see what happens when we put together the whole numerator and see what that value is. Okay, so now seeing that again, our g prime value was just 1, I'm not worried about that. So I took my f prime g value over here and subtracted the f value that we have right here. And now here I just need to combine terms. So we're going to have 2/3 x minus 2/3. And then combining our x to the 1/3 term, this is actually going to be minus 4 over 3 x to the 1/3. But now with this value here, what I notice is if I just factor a 2/3 out of this, then let's see, this value right here will become a minus 2. So if I write it this way, our numerator is actually right here, and we've just multiplied it by 2/3, a constant value. So what I can do is take my f value and multiply it by 3/2 to reverse this, and then let's see what we have. Okay, so just multiplying by 3/2 here, you see that now our f value is 3x to the 1/3. We could get our derivative, but we don't really need it at this point. But if we do get the derivative of this, it's just going to be x to the minus 2/3. So at this point, we actually know what the solution is. It's going to be this f over g that we have right here, but I think we should go back and validate it. Okay, so we have our solution here of f over g, and I'll just add my plus c on here to be correct. But now let's take the derivative of this with the quotient rule just to verify that we've got everything right. So for f of g, for our derivative, we're going to have the derivative of the numerator, so that's going to be x to the minus 2/3 times just the denominator, which is 1 plus x. Then we're going to have minus our f value, which is 3x to the 1/3 times our g prime. The derivative of this is actually just 1, so we don't really need to write that. And then we're just going to have the denominator squared. And then if we just distribute this in here, we're going to have x to the minus 2/3, plus when we multiply this in, we're going to have an x to the 1/3 minus 3x to the 1/3 over 1 plus x squared. But you can see right here, we have 1x to the 1/3 minus 3x to the 1/3. I could just change that and make that a 2. That matches exactly this, and so this is correct. Okay, so we'll stop it there. Thanks everyone for watching. Have a great day.